Hi. So, welcome. Um, Today I figured I would get the layout done for this board. I really want to get it, I want to get it ordered by like Monday or something. So I am trying to get this done, but also figured I should stream it while I'm doing it because it's an opportunity. So I'm designing a memory card here. I laid out the board, or designed the schematic. What was it, on the weekend? This is intended to be sort of a stopgap until I can make a more complicated board that has much more memory. This one is going to have like 4 megabytes probably. I could possibly get 8, but I'm gonna lay it out as a 4 megabyte 4 chip board for now. And this is of course interfacing to the VMEbus. So I've got a CPU card that I designed earlier, and I'm going to build that. I'm going to order it at the same time and build it, and then this is to allow additional memory for that system, and also memory that can be used to coordinate multiple CPU cards, which is the eventual plan. So yeah, this is a fairly simple board. The logic is this. There's no programmable logic. It's entirely static logic. A couple transceivers as well, 4 memory chips, as I said earlier, and then the bus. This is 1 connector, not 3 connectors, but it's broken out because there's 32 times 3, which is 96 pins on that connector. What else can I say? Yeah, it's not going to support the extended multiplexed 32-bit cycle with 40-bit addressing. I might do that on the CPU card, and then I'll test it some other way. And any future cards I make will probably try and do that, but it does add a lot of complexity. It would pretty much double the number of logic chips that I need for this. So avoiding that, just doing 24-bit addressing and 8 and 16-bit operations. The one big thing is that it's going to have 5 volt or 3.3 volt chips. There are some pseudo-static RAM, which is actually like DRAM inside of a chip with its own memory controller, which is only like $5 for a megabyte, versus $12 for actual static RAM. And they're a bit more varied. There's pretty much only like 1 or 2 chips that are 5 volt that are 1 megabyte, because that's quite a large size for static RAM. So making it dual voltage will give more options for that. So let's open the PCB layout. I've already copied the board from a previous project, system board. I copied the connector and the holes that are used to mount the front face. And I imported this little graphic of a woodcock. Let's see if this actually works. Did it delete things? Okay. Oh, it does move it. Darn. I'm trying, this connector is already in the correct spot, so I don't want to like get rid of it. Okay, that works. I'll just chuck these here. Okay. Oh, right, it's locked. Unlock it. Copy this one. 132.8. Can I just move this in place? 132.8. Oh, that would be why. What if I go back to here, change this to U2, and then do the import and replace the parts. There we go. Done. Oh, I'm being silly. Let's see here. These are all the logic chips. This is also a logic chip. These are the memory chips. Oh, these are the memory chips. And then these are the transceivers. That is clearly the data transceiver, but right. You have to be upside down. Out of the way. Well, that's kind of annoying. I like to put all of the chips facing the same direction so that it's easier when I build the board, because I never remember that this is upside down. Because I just don't fucking check that. I did at one point have a footprint. Let's go back to the schematic and see if I can find the footprint that I made that has arrow pointy bits. And I see that I don't have the footprint library correct. It's probably not going to be in that one, but this one has miscellaneous and through hole. What are the libraries? This one's not a thing. Mechanical. Oh, front panel stuff and connector stuff. Okay. I'm just going to close those and wait, what? Got those. Why wasn't I seeing them? I'm looking for a symbol. Oh, because I am just not paying attention, that's why. But they didn't have the thing that I wanted anyways. Did they? That's the thing that I want. Right? These ones. Only got 2. Put a big old arrow on it, but it's otherwise a different one. Kind of like the updated one. I'll leave it for now. I can always just like substitute out the footprint. But these all gotta be upside down. Alright. Might as well make that one upside down too, or does it have to be, or does it have to not be? It has to not be. Now, is that a mistake? This is the time to be catching mistakes. This is BA, BA. B is bus voltage, A is mem voltage. Is that the one? Yeah. What was the other one? Is it ALVC? I'm calling it ALVC. 164,245, which is the dual voltage supply. But I am actually, I believe I have the NXP one, or the Nexperia ones, as opposed to the Texas Instrument ones. Should I look up the other Texas Instrument, or the Nexperia of the 8-bit one? There is no Nexperia one. There's only one that's like a different logic family. Okay, well then I guess I'm using the Texas Instruments one. Port A has the lower voltage. Yeah. And now I am just looking up the I'm looking for a 24 pin um, 5-volt part. Oh. That one. Literally the only option is this one if I were to do the 5-volt. Is this compatible? The ABV, not connected. CPAB, CPBA doesn't look like the same pinout. Like ignoring the voltage part of it. Pin 2 would be dir, pin 3 is dir. Well, shit. Now I'm wondering, like, can I even build the board for 5 volts? Maybe I can only build it for 3 volts because of this one part. Because it's got to be that one in order to get the bi-voltage, dual voltage, dual, whatever. Is this is dual voltage? Yeah. It doesn't say on the title that it is. The way this one says dual supply translating transceiver. That's what we want if we want 3 volt, or if we want 3.3 volt logic, or even 2.5 volt logic, or RAM, I should say. But if we want 5 volt, we need to be able to switch the parts out, which we can do if we use a different transceiver chip. I mean, this thing is only, this particular chip is only being used for a few signals, and it's the address stuff, which isn't as important. I just want to translate voltage. I want to either translate voltage or Nothing. Remove the chip. Have bypasses. Oh, that's an interesting idea. Because I don't need if I wasn't trying to translate the voltage, I could potentially have it go straight in. In which case I could put some soldered jumpers. And then essentially when you're using 5 volts, you would just not populate this chip and solder close the four jumpers. These are just 3.3 volt. They're not translating transceivers. Oh, what if I did that, which isn't matching anyways? Let's just do it with that. Well, that's 2 elements. No, I want 1 element. Sorry. One element. But specifically these ones. Width isn't too important. Let's just check them all. 87 still. Dual supply, 8-bit translating. Okay. Wow. Oh yeah, this is what I would like. LVC 8T245. This one. What was the symbol? This one. Yeah, this is one of... Okay, I'm going to duplicate it. And we're going to do ET245. What is the behind bit? This one, PW. Okay. That's that one. And then there was this, which is, according to this, it is also VCCB. And 2 grounds on that side, 11 and 12. Wait, what? Oh, right here. 11 and 12. And 13. Eleven, 12, 13, all ground. Okay. This one was B, double checking. 23 is VCCB, right there. Like that. All right. Oh, and we should change this. We have a reference to this, which is that. Bit dual supply, directional gen. Close enough. Okay. Yeah. Change symbol to our new one. Should just be the one. Was hoping that would just like update for me, but I guess not. It's okay. Update that one. We got the right bus voltage. Okay. That doesn't actually solve my problem. That's just the better one. Wait, but now I can look at these and see if there is a 5-volt 5. Oh wait, no, that does solve my problem anyways because it was a this one clearly says that both ports could be 5 volts, so we're good. We're not forced to do. So it was this one, which only allows 3.6 volts on port A. But we're ditching that one and we're doing this one. Yeah, we could also like use another one. Maybe there's Texas Instruments. There might be one that's not LVC, AXC. Is there an ABT or an FCT? There's an S. Oh, that's the different one. That's the one with the different pinout. It's a different part number even. Yeah. Okay. Good enough. So right, we were saying that this has the pins on the internal pins are on this side, and on this one it's reversed because this chip is upside down. So let's just check our datasheet stuff. Our pinout has port A on, directions are hard. The left, B is on the right, and our other one, that is not it, this one, has port B on the left and A on the right. Okay. That's a fucking pain in the butthole. Why did they do that? Why did they do that? That wasn't very nice. They could have not done that. I guess it doesn't really matter other than that we want to make sure that a high makes B the output and a low makes A the output. A high makes B the output, a low makes A the output. Yeah. Okay, so our dir logic is the same. The pins are labeled differently on the different side, but there's not a mistake. I just want to prevent the possibility that we would like hook this up and then find out, oh, actually the chip needs to have been rotated, but we can't rotate it easily because then we've got to like rework the logic and the power pins and pain in the butt. Pain in my butthole. Where are they? Oh, they're there. And then the address pins are actually low, so put that over there. What else do we have here? We have a voltage regulator. This was something to do with the voltage that the board is using. For the memory. Maybe that makes it, or whoops, I'll do that. No. Move that over. I'm just trying to like roughly put things in places where they should be. C1 and 2 are for the regulator. C1 is the incoming. That goes somewhere around there. And that goes like somewhere around there. Put the test point over there. I have 3 connectors. That's probably excessive. I want the connector to move. Get it all, maybe not quite that close. Is this off? I always have this happen where I do all sorts of things and then realize, oh, actually they're not snapped to the grid. There, that looks snapped. Oh, right, I put a power light. Or this is not a power light. This is a voltage regulator light. Maybe it doesn't make sense to have that there. So we'll just move that off for now. That was for the oscillator. I have these jumpers. All right, these are the address. These are the address select jumpers. This is for the optional oscillator. For the optional detect timer. So that chip is optional. Those caps are for that. This one should be on this somewhere. Oh, and one of these is part of the optional circuitry as well. This is optional data acknowledge. I am probably going to build the board without that, but if I need it, I can put it on. So just saving myself some problem later on. These ones are not optional. These are the open collector, 2 open collector gates. Rather than put one of these on, I'm putting two of these ones on, but honestly, I probably should just put one of these chips on. These, that is for that, which is related to the optional stuff, and then that is related to the... This one is the thing that selects between the optional and the non-optional, or the optional and the like just bypassing thing. And this selects which clock to use, whether to use the onboard clock or the backplane clock. There's a clock pin on the connector, but it's only like 16 megahertz, so. Let's see, while I'm here, I am going to switch some things. Can I? No. I have to do it one at a time, I guess. Sorry, just checking my phone. The mindless parts of board layout. Make that a silk screen, or make that is the wrong one. This one. Make that not the silk screen. Ah. Okay, these ones too. I'll get those ones later. I should probably get back to just laying things out. So what do we have here? C3 through C8 are... Wait, did that actually work out? Oh, no, because these aren't actually... These didn't work out. I mean, they're just in different orders. Why did I put them like that? Could still make it work out. So like U3 has C3. Oh gosh, now I can't not do that. I mean, that's just too perfect. So then 3, 4, 5, 6, 7, 8. Just go there. Oh, shit. All right, there we go. C11, where the fuck are you? You are the optional things. You're there. 12. Transceivers. 12, 14, 13, 15. Twelve, 14 is U13, yeah. 13, 15 is U14. And you're up there. And 16, where? 16 is the bus side. And 13 is the bus side. Roughly like that. And 12 is the bus side. I don't know where I'll put the optional logic. I don't know where I'll put the non-optional logic. I don't know where I'll put the RAM chips. Would it be easiest to organize the RAM chips vertically? think so. Apart from chip select, they should all just be the same pins. Okay. We will make them vertically oriented. So, this is going to be a problem, isn't it? Do I have enough space? I also realized I don't have bypass caps for the RAM chips. Guess I should have bypass caps for the RAM chips. Do not copy those. I said do not copy those. It always takes longer than I think it should be for doing this like layout, like just getting the positions right. I mean, come on, it's not that difficult. It only determines everything. All the difficulty you may or may not have when laying out the board. I mean, no big deal. I'm joking if that wasn't obvious. I can move it up, so I will. Clock, no clock. That is that one. Good. Don't need to see that. I'll fix up most of the labels later. So the control signals will mostly be coming through here. That's the data stuff up there. The bus stuff we don't need to worry about. The bus arbitration stuff. Where's all the other shit? The addresses are there. AM. Or sorry, AM. Address modifier, or address mode. It's something like that. There's VAS, the address strobe. And then write and long word and DS, VR. Those are the ones I need, the main ones. They're in here. So I could slide these ones up or down. And then it's mostly going to go into these ones. Also, what's our spacing here? 10 millimeters. I believe I did something like that for this. Eight millimeters. So I could move them a little closer even. Although this is, technically it should be a 160 millimeter board. I'm doing a 100 by 100 millimeter board in this case, which is the same as the system board that I did, which was also fairly small and didn't have a lot on the board. It's going to be a lot cheaper to print it, and it's just a memory card, so there's nothing showing here anyways. I've got this LED, but other than that, and that's really just to show me that yes, the voltage regulator is working in case, I don't know, something dies or I'm questioning the validity of the board at some point, and yeah. All right. I should snap these. Get these right. Snap that way. Yeah. Oh, right, and bypass caps for these. I actually at one point got away with not putting bypass caps on the 68030, and I guess I had enough other caps elsewhere on the board, it didn't really matter. So part of me is like, oh, is it really that important? Well, I probably should put them on there. And I'm going to copy the transceiver ones. Okay, need a bit more space. Don't do that. Okay. Why does it keep doing? Because I keep pressing redo drag Control Z instead of Control P or V. Right. I guess that's actually, that's the wrong button. This one, reset annotations, we're probably going to get, yeah, I did 18, 19, 2021 instead of what I previously had. Import, and we get the 4. Oh, I forgot to copy something incredibly important from system board. Or did I forget to put them? I did not put them on system board. Ooh. This. This line. This line. I don't have the option to copy from an offset. I want it to be in a very precise position. I don't trust that those are right. 2794 and 12294. I really should have made these in the exact same spot. 3175, 3425. I can't math right now. Are you kidding me? 2.5 millimeters. That was easy math, but my brain is not having a happy time today. 2.667. Not surprising. Okay. Oh, fuck you. $25.273. Did I have that just not good on this one? Yeah, I didn't copy that right. Okay, 25.4 is what I put on that one. This one. So much easier when this is like all standardized and in known positions. Uh, 25.4 plus 2.5 is 27.9. So this line, 27.9, 27.9. Oh, let me just check that. 2.5, good, okay. And this one is 125. 125.4 minus 2.5 is 22.9. 22.9, 22.9. All right, there we go. And then we can lock these ones. Oh, it's locked. This is the clearance area. The card will slide into some card guides above and below the card. So that's the thickness of it. Anything in that space will prevent the card from being inserted correctly. So we need to move this down. We need to move the whole chip down and move this capacitor down. Can I select the right things? Jesus. Jesus. It's going to be pretty hard to put in there. Stand it off a bit. That's a good enough spot. kind of just fits. All right, so that's the memory chips in place. I can slide it over this way. I'll probably end up putting this like at the top, or actually maybe I'll put it here and I'll put the logic up here. Having the logic vertically like this actually will make it easier to assemble. And then I've got buses coming through here. This is going to be a bit too low. Let's move this up a bit. I don't really need that many. I don't really need this many connectors. Let's remove that one. There we go. Okay. Move that down a bit. All right. And I mean, I'm not pressed for space, so I could, again, move these a bit closer. They're 10-ish. Move it one over. I want that one. Get them all lined up. Oh. That's kind of weird. The arrow for the pin 1 is different between those ones. They're all, this one's a 16 pin one and the rest are 14 pin ones, but kind of odd that that's just inconsistent there. Might as well do these while I'm at it. Put these onto the silk screen layer. And then let's get these snapped. I don't want to move it too far from where it was. Which one is this? The center one. Without that. Without that. There we go. Look center-ish. Center-ish. So there's 6 pins, or 6 chips. And oops. That's about like center of the board. But it is a little cramped down here. I'm thinking about the buses. Where are the buses? Oh shit, I also forgot about this shit. The buses. The data bus is going to run along the top because that makes the most sense. The address bus is going to run along the bottom, so I kind of need space in here for the address bus to go through. Should be possible to afford more space for here for soldering, for building the board. I'm thinking always about how easy is it going to be to build this. I want lots of space, and I want my iron is going to be coming in at an angle. And so for things like this, obviously these being right next to each other, I'm going to move them up, but that would be difficult to solder. That's why I've got these ones in between here, because it'll be easier to put my iron onto this pin where this area right next to it is going to be, if there's anything here, it'll make it harder for the iron to get in and lie flat. So having space is a big concern. I have these the spacing between them is less important because the iron is coming in onto these pins, so space between, horizontally is more important than having space vertically. Although if I was using quad flat packs here, then that would be a concern. I would have to have all four sides have space. So I could break these two sets of chips. I'm just going to start putting them into a better spot. I could break them into two columns of 3 instead of one column of 6, and then have more space for these. I can also move this down a little bit. This I want to put up here. And then get these little capacitors in here. Do it there. Oh, because that's snapped. Let's get this. That's a little tight. I'll do that. Test point is easy, and then this is the memory voltage. Although that's going to affect everything, not just the memory chips. It's going to affect everything except for the second supply of the transceivers would be on MEM voltage, not bus voltage. Let's reduce our snap a bit and get these a little tighter. Is that going to be a problem? I won't get it too tight. Leave it there. Okay. I want to get back to that other snap though. Okay. So still kind of questioning where to put these. Don't need these on the silk screen. Oh, right. Where the heck can this go? Gotta be close to the 74HC14, which is the hex inverters. And it is the optional part. But it's also like, yeah, in there. So really it should be there. Like it should be in the top part. And then it's kind of like, well, how low can you go here? But, oh, but you got, I got this bus. I keep forgetting about this bus. So what's kind of the limit here? Oh, I maybe haven't set my set up my board. Design rules. I have not set up my board. I'm gonna copy. What do I have for this one? That looks better. All right. And then you've got the 4 on this one. It's a little tight. I would like to have more memory there, or more space there. Sure, just stick them there for now. That's almost 9 millimeters between those chips. 9 millimeters between those, and it's probably going to be that. Yeah, for that. Could possibly even move it a little closer. And then I've got plenty of space on the bottom for the address bus. And even with this stuffed in there, I will also have enough space for the data bus. Oh, stop snapping at that. It's a little tight. That should be plenty of room. How do I feel about this layout? It's all right. Seems a little squished in the center. Also kind of a little off center. It's because this seems off center, because it is a little off center. It's also off snap. Here we go. It's a midpoint like there. Just kind of like right between where it is. Yeah, that's good enough. All right, what would it look like if we just made these go over here? Yes, that's a point. Now that I'm looking at this, I'm thinking like, well, actually, because we can't cross over on this layer, we want them like over there. But that's okay. Yeah. For this board, you see, I managed to get the address lines going down the center of the board. But there was, these are the same memory chips. There's only enough space for the address, or for about 20 or so signals to go vertically, which is to say that we need some of the signals going along these sides. But what I'm really just trying to figure out right now is how much space do I have to work with? And this is going to be harder than I would like it to be. Also, that is ground. Don't need to root ground. Okay. I mean, it's looking pretty promising. This is packing quite tight. All right. Something like that, which is like plenty of space. Oh, 5 millimeters. Got plenty of space. Okay. Do I want to spend a whole bunch of time arranging all of the labels and making them all perfect right now? Really? No, I don't really want to do that. Get to some actual traces instead of just moving shit around the board. Ugh, I hate it. It's like 2 hours I've already been. And all I've done really is move things into places. I'm just thinking, what do I want to do first? I think I want to get the memory chips done first. Okay. Starting buses is always hard. You need to get, like, you can easily get tripped up later on. But then I end up, like, freezing up more than I do, like, getting shit done. I don't have the space here because I put the capacitor here. I can put the capacitors on the other side, but then I've got to go around the capacitor anyways. I could have the wires go in here. They need to be, like, reversed, but that's okay. Do that, and then that goes up. Just noticed I was on the wrong graphics. Seems to sometimes do that. I hope it wasn't too laggy. Probably was terribly laggy. Alright, well that's a lot better. So this idea would be like going up. Even having these like I could even put all the vias over here. I could have it go flip over there. And then these ones are actually going to go down. No, I'm gonna have to go onto the bottom layer for those ones. Actually, this I want vertically as well anyways. Put it there, put it there, put it there. Hi, Bad Nintendo. Welcome. I'm using KiCad. It's open source. All right, going up. And these guys go up. Do you think? Yeah. Yeah, those ones will come from the bottom, so that's okay. So that's probably as close as I can get. But these guys can come in. Get that over. Whoa! Don't do that. Bad Nintendo asks, nice, you gonna build this or just playing with software? I'm planning on building this. This is actually the, this is the quick board that I'm trying to do in like a couple days, and then I'm gonna order on Monday. The CPU card is the main one, and that was the one that took like, I mean, on and off like a month to do maybe. This one I just started tonight. I just started the layout tonight. Did the schematic on the weekend. Why'd you do that? Oh, Thanks. Wouldn't mind being a beta tester for it when it's ready. Thanks, but I'm going to. I'm probably just going to make one board, build it for my own uses. This is just memory. Plan to do the bring up over December. This one should be fairly easy to like bring up. This is going to be. There's no programmable logic. It's just static chips, and I might have got something wrong, but I can always fix it. And if it's completely unsavable, I'll probably just make another board. Like completely design. Brand new board. Oh, nice! Yeah, I'm working on, Bad Nintendo says, yeah, I'm working on a CPU GPU combo, but only just started learning. That's great! What CPU are you using? Making it from scratch, eh? That's pretty awesome. What kind of bit width are you thinking? Wait, that's UDS? That is UDS. Don't need to root that. Good luck with that. P versus MP. Do I want to put all the vias over here? Maybe. I don't know. I'm certainly going to need more space here, though. Not that one. Oh, it went all the way over there. And 8. Just enough space. That doesn't seem too bad. Okay. Now I'll put the, I'll connect these up. So the bus will go up. But I also need to cross over. Missing D0. Put it up like that. All right. Can't make it go backwards there. Maybe I don't want to. Like here. That's maybe a little tight. Oh, because I'm not limited on that side, that's why. I'm like wondering why this is different spacing. Nope. I think I'm going to quickly run out of space here. It's not perfect yet, but it's just like trying to get the spacing right. Cause I gotta run all these traces up and down the board. But that's kind of the data bus sorted. Got enough space in there. I've got space to move it up if I need. So now the address bus. For these pins, I'd like to do them going over this way. These ones are actually going to need vias all throughout. So I want to make sure that the spacing is enough for a via. Looks like I can maybe get away with one more. Go. Should work. Should put that in first. Otherwise, it will tell me I can put them closer than I actually can. And I'm concerned about running out of space, as usual. Horizontally here. I've got some space I can move this over if need be. It is close to the edge of the board, but and I need to go through or around these, which actually no, I can go straight through it because it's on the bottom of the board. Oh, but I've only got these ones on this side. Okay, I've only got four more. Five more. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 4. There we go. So for the other pins, I just had them all come out and go straight down. But they're kind of in a weird order. 5, 4, 3, 2, 1, 19, 18, 17, 16, 15. I want to see what's the most convenient way to go down here. So that I don't have to have a whole bunch of shit crossing over. And I'm gonna have to have a whole bunch of shit crossing over. Yeah, even if I like do it the other direction. Well, that's not gonna work there. So it's more of a like do that. Nine, 10, 11, 12, 13, 14, 7, 8. That's it. That's not very many. And then I'm thinking the data bus will go down the center on this one. So oh, 8. Yeah. Okay, we're going 16 to 1 there. So I'm thinking like 14 is our biggest one. So thinking of having this be the leftmost signal, and then having that one stick out. So it'd be something like that. And then this signal being 14. We come down here. I hate when it doesn't join like that. Well, that is kind of wrong anyways. This should be going up here. Yeah, I'll probably do it like that. I'm getting a little tired though, so I think I'm gonna call it here. Thanks for joining. Might do some more tomorrow. Like I mentioned earlier, I'd like to get this designed over the weekend and then order them on Monday. Either that or I order parts on Monday or order parts on the weekend, hopefully get the parts on Monday or Tuesday and then order boards on Wednesday. That doesn't really give me enough time. I guess it gives me enough time. I want the boards to arrive like mid-December. I generally like to order parts before I order the boards because once I got the parts, if I get wrong parts or I can't get parts, then I can always adjust the board design at that point. But yeah, that's it for today. Thanks for joining if you joined. Hope you enjoyed it if you did. Talk to you later. Bye.